What's going on, everyone? Hope you're having an awesome weekend so far. Today, I wanted to just keep it short and sweet. Watch the Decoding the Universe full documentary on Nova about the quantum physics, quantum mechanics, and quantum computers. I want to specifically just roll a few of the clips and give some reactions and call it an evening. Hope you're doing well, and let's just jump right in. Oh, and before I have a couple exciting things in the work. I kind of dropped this yesterday in my video, which was a little bit on the longer side, but also I really wanted to go into kind of my just gut feel and reaction to some of these clips. So I watched the video and then I just hopped on here and I just wanted to record some unfiltered thoughts. Why I'm so incredibly bullish on quantum, all the signs. There's just so much, like the more you dig, the more meat there is on the bone. I've said it before. So anyway, this announcement coming tomorrow or at the latest Monday, I'm hoping will add massive value to all of you who are subscribed, and hopefully value to the sector of quantum computing in general. That's my goal. So excited to share with you. Stay tuned, and let's jump right into this video reaction. All right, guys, let's jump right in. I definitely recommend watching this whole documentary. The last part was specifically about quantum computers and quantum entanglement. Fascinating stuff. Looking forward to showing you and discussing it a little bit. This was posted 2 months ago to Nova PBS official YouTube channel. So let's take a look.
Arguably, the most important change in quantum physics in recent decades is a deeper understanding of a special kind of shared state called quantum entanglement. Imagine a machine that spits out pairs of coins, which on the surface look like ordinary coins. If you flip one, it comes up heads or tails, about 50% of the time. Nothing strange there. But using a pair of coins fresh out of the machine, you flip one, it comes up heads. And then the other, it also comes up heads. That could just be luck. So then you do the same thing with another fresh pair. This time the first coin is tails, and so is the second. Agreement again. So you flip another pair, and then another, and another, and another. Pair after pair, the two coins always agree on the first flip. What's going on? Maybe the first flipped coin, once it comes up heads or tails, is somehow telling the other coin how to behave. To make sure that can't happen, you separate the coins by flying one to the moon and flip them at the same time, so no message could possibly travel between them. Still, they come up in agreement. It all sounds too strange to be true, but particles really can behave like those coins. In quantum physics, it's called entanglement.
Entanglement is really just a stubborn, exciting and/or frustrating fact that takes a long time to try to get our heads around.
Entanglement is certainly the most interesting and the most confusing aspect of quantum.
It's one of these things we don't see, naively in the world around us, but it is taking place deep in the materials.
Did y'all see that article? World first. Quantum entanglement of molecules at 92% fidelity in the UK. Pretty cool. This shit is happening right now.
Exist around us every day.
Okay.
And while you probably won't come across a coin entangler anytime.
Going to another part that I really liked. Loved this.
But perhaps with the greatest fanfare in quantum computing.
Yay!
And
That's
starts
us.
with this.
That's us bulls. That's quantum bulls, right?
The qubit. The qubit gets its name from its cousin in classical computing, the binary bit.
I love this so much.
Like its name suggests, a binary bit can only be set to 0 or 1. But from such humble beginnings, much has flowed. More or less, all the computing that makes up the modern world.
All calculations, all emails, whether you're talking to your friend or whether you are a NASA scientist doing some rocket calculation, all of that can boil down to just zeros and ones switching inside your computer, which is kind of amazing that it's that universal.
Despite its many successes, the binary bit is the equivalent of a light switch, on or off. The qubit is far more subtle.
Quick pause. So last night when I was rambling for like 30 minutes, I just watched this whole thing. I do recommend the whole thing, watching the whole thing, but we're just gonna pick out some nuggets, and this explanation helped me wrap my head just tiny bit around all of this. No pun intended.
The special thing about a qubit is that it operates by the laws of quantum mechanics. It doesn't have to be just in the 0 state or just in the 1 state. It can be in a superposition of both.
That superposition creates a mathematical space often represented by a sphere.
Where a classical bit can only sit at the South Pole or the North Pole, a quantum bit can be anywhere on the surface of this sphere.
It opens up a whole new array of possibilities of mathematical operations.
But a single qubit will only take you so far in computing.
One qubit by itself is not a computer, or it would be the world's smallest, most useless computer. But when you combine them, it can provide enough computation and calculations that you can get something on the other end.
Using several qubits together opens up the power of entanglement and unleashes mind-boggling levels of complexity.
If I wanted to give a
This is what's happening right now, you guys. This is why I made this channel. This is why we're here. The science is somewhere between reality and fiction, but no matter what our personal feelings are about it, this is coming, and it's coming fast.
complete description of what's happening with just a few hundred qubits, very highly entangled with one another, I would have to write down more bits than the number of atoms in the visible universe. And it's that extravagance of the quantum language that we wish to exploit in a quantum computer.
Beyond the work being done at universities, there are about 100 companies developing qubits and quantum computing hardware.
That's us. Look, T-Wave. Where's Rigetti? Rigetti, where are you?
Major players include Google, Microsoft, Amazon, and IBM.
No, Rigetti. Anyway, yeah, IBM, freaking crazy. Okay, so go watch this video in its entirety and have a great weekend. Super excited. More soon on some of the announcements. All right, that is a wrap for this video. If you've made it this far, you are probably just as interested in quantum computing as I am. Please consider leaving a like and subscribe if you haven't already, and we will see you all next time.